Okay, so balikan natin yung example natin kanina. So this is basically equal to your normal force going up minus your weight. Okay, so paano kung tinutulak na natin to? Let's say we apply a force to the right, no? Positive. Okay, however, hindi gumagalaw. So, ano nangyari? So, nag-apply ka ng force, pero meron kang counteracting friction. Okay? Let's draw that. So, tinutulak mo siya papunta doon. Pero hindi siya gumagalaw kasi may friction. Magaspang yung baba. So, dito sa along y natin, along x pala natin, hindi na zero, no? Kasi tinutulak mo siya eh. So, zero pa rin pero hindi na zero yung mga forces that are there. Nag-counteract lang yung mga dalawang forces. So, although zero yung total force, yung net force, meron ka ng applied, force applied. So, tinutulak mo siya pa right, pero di siya gumagalaw kasi may friction. Okay? So, again, application to ng third law din. Uh, third law of motion. For every action, there's an equal opposite reaction. So, yung applied force mo, kina-counteract ng frictional force. So, yung enough force, para gumalaw siya, sa experiment natin, so, nasa bandang 100. Okay. So, parang yung border niya na gumalaw siya, yun yung border ng force applied to force applied minus frictional force is equal to zero. So, yun yung borderline. So, above that, if you give it enough force, gagalaw na yung object. Okay? So, basically, these are the two forces, yung parang borderline na equilibrium pa yung mga dalawang forces. So, from this, you can see that meron kang dalawang uh, forces along x, dalawang forces along y. Okay? So, if this is zero, we can simplify this as equal to force applied. Lipat ko sa kabilang side yung frictional force. So, is equal to frictional force, no? So, basically, any force applied above the frictional force will allow you to move. So, makakalculate natin yung border, yung mismong enough, yung minimum force na kailangan mo para matulak yung bagay. Okay? And then dito sa y naman natin, we can set na normal force is equal to your weight. Okay? So from the lab, no, we know that the frictional force is equal to u sub s. Hindi ko lang masulat yung s times the normal force. So may connection na itong dalawa. So yung frictional force mo, may kinalaman sa bigat ng object. Kasi yung normal force mo, related dun sa weight. Kasi kung mabigat yung bagay, mas mataas yung normal force. So the heavier the object, the greater the normal force. So connect kita natin dito yung connection nung forces along x and forces along y. So the reason why it is hard to push a heavy object is because the frictional force is related to the normal force. Okay? So, kung kanina, kung minimum force natin 120 newtons, gumalaw na. Okay, so gumalaw na siya sa 120 newtons. Paano kung dinagdagan pa natin to? So, okay pa ba yung 120 newtons? Hindi na. Okay, so kita natin na related ang frictional force at saka yung normal force. Okay? So, pag may problem ka that is that has frictional force, katulad nung experiment nyo nung isang week. So, if weight is given, the mass is given, you can calculate for the normal force. Therefore, you can calculate for the frictional force kung given yung coefficient of static friction. Pag given yung static friction and normal force, you can calculate for the coefficient of static friction. Okay? So, ayun, yun yung ginawa niyang experiment. This is actually an application uh, of Newton's first law. Okay? So, the heavier the object, mas mahirap itulak. So, kanina nag-apply tayo ng 120 newtons gumalaw. So, dapat doble. So, kaya pag mabigat na bagay, mas mabigat, mas kailangan ng, dahil sa friction, no? Mas mahirap itulak ang bagay kasi dahil sa weight niya. Okay? Clear ba yung concept na yun? So, mamaya or tomorrow, magbibigay yung example. Paano ko inclined plane, no? So, ano naman yung contact forces doon? So, we will talk about that tomorrow. So, this is a simplified view nung pag application ng first law of motion. Release ko na to. In-explain ko lang yung experiment nyo nung isang araw. Okay, so balik tayo sa PowerPoint. Okay, so an object will at rest will remain at rest as long as no net force are acting on it. An object with constant velocity continues to move with the same speed and in the same direction as long as no net force acting on it. Teka lang, break lang tayo sa example, no? Uh, Take note, pag wala tong friction, so yung earlier na, yung example ko nung last week about the key na paano ko nag-brake yung car, saan pupunta yung, kung halimbawa, umaandar yung kotse, tapos biglang nag-brake yung car, saan pupunta yung susi? So, pupunta paharap, okay? So, wherever the direction of the motion is. Kasi, yung, yung motion ng car will be the same as the motion of the passenger at saka ng susi na nakasabit. So, kung nagbiglang brake ng car, kung walang seatbelt, tatalsik yung tao sa paharap. Okay? So, that's prone to injuries. So, kahit nag-brake yan, tuloy-tuloy pa rin yung velocity ng mga uh, pasahero sa loob. Kung walang seatbelt, then prone to injury. So, malaking bagay yung seatbelt, no? So, pwede natin ilagay sa application of the first law of motion, yung seatbelt, kasi it prevents the damage caused by continued motion of the passenger. Okay? So, yung seatbelt, yung parang pinipigilan niya yung injury caused by the first law of motion. Since biglang break yung tao, uh, yung seatbelt yung mag-stop ng person going forward. Okay, so yun yung application. So, ganun din dito sa car. Pag naumpog niya yung wall, yung tao tatalsik. Alam ko may animation to eh. Anyway. Okay, so when forces are balanced, the acceleration of the object is zero. So an object at rest, the velocity will be zero and the acceleration will be zero. Pag in motion, hindi velocity will not be equal to zero, but it will be constant. The acceleration will be zero. So pag sasum mo lahat of all the external forces on the object, basta take note, no? So ang tawag dyan yung concurrent. When we're talking about a free body diagram, yung mga forces are acting on a particular point. So we call that concurrent forces. Mahirap mag-solve ng problems kung wala kang free body diagram. Okay? So we treat the object as a point, and then we analyze the forces that are acting on that object. So if the net force is zero, forces are balanced. When forces are balanced, the object can be stationary or moving with constant velocity. Okay. So, yun, balik tayo sa concept ng mass and inertia. So, every object continues in a state of rest or moving in a straight line unless there is a force that is created by unbalanced forces acting upon it. So, property ng any matter, since may mass ang matter, is inertia. So, you resist changes in motion. So, the mass is a measure of the amount of inertia. And mass is a measure of the resistance of an object to changes in its velocity. So, mas mabigat yung bagay, mas mahirap i-change yung velocity. and that's inherent property of an object. So the standard unit we have is kilograms. So that's the first law. Okay, yung second law of motion, so the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass. Okay, so ito yung drawing ko na summation, no? Kanina. So you sum the forces along a certain axis. So doon mo makakalculate yung acceleration. Okay. So ganun din yung gagawin natin sa object. Kung may acceleration siya sa x or y, it is basically due to the uh, net force along x or along y. So this time, hindi na zero yung net force. This time, you're giving it a constant acceleration. Okay, so let's go back to the original, to the experiment. So this time, we will, so alam nyo ulit, no? Normal force and the weight. So hindi naman, kung walang friction siya, oh, wait, hala, wait lang. Okay, so this time, we're gonna put values here. So yung applied force mo will give this object its acceleration. Okay? So mas maganda yung gamitin natin yung isang example. Ito. So perfect. So if it pulls towards the left, may acceleration siya towards the left. Okay? So merong siyang counteracting force, pero since yung net force, the sum of forces will give the overall force towards the left. Then, so since force is equal to mass times acceleration, the acceleration will be due to the net force. Okay, so laging tandaan. So meron kang 150 newtons going to the left, tapos may 50 newtons going to the right. So magpa-cancel out yung 50. So yung net force may 100 newton. No? So in other words, kung susulat natin yan in terms of an equation, so the summation of force along x is equal to yung force papunta sa left. So let's label that F1. So itong force again, mag-free body diagram tayo. So let's treat this cart as a point. So, nandun siya sa center. Lahat ng forces will be acting on this point. Okay? So, uh, hindi naman um, hindi naman taken into account yung friction. So, we assume na frictionless yung surface. So, basically, yung forces along X is just equal to your F1. So, since ang convention natin F1, ito na lang yung positive ng F1 na lang tong red para kasi positive direction siya nagpo-pull. Itong dalawa kasi negative direction magpo-pull, so kaya binigyan natin ng negative. Okay? So, yan yung convention natin. So, yung forces along X, ito yung force na na-exert niya. And then, dun sa kabila, so mas malaking force, pahabaan natin yung, okay? So, yan. Since meron kang hindi balance yung nangyari. So, meron kang net acceleration. Okay? So, yung summation of forces along X, F1 minus F2. So, it should be equal to the mass times acceleration. Okay? So, yun yung meron kang mass nung whole system times acceleration. Okay? So, hindi naman given yung mass nito, pero ang point is, makakalculate mo yung acceleration. So, if we divide the F1 minus F2 divided by mass, we can get the acceleration. Okay? So, since yung standard natin, di ba, papunta sa right is positive acceleration, papunta sa left is negative acceleration, it will have a negative value. So, negative yung acceleration mo. Okay? So, ganyan yung pag-calculate. So, pag maraming forces along X, then you put all, kaya importante yung gagawa ka ng free body diagram para ma-analyze mo kung ano mga forces. So, magdadagdag tayo dito. So, this time, so ito yung F1, no? Baka malito tayo. Kasi positive yung F1. So, dito yung F1. Kasi positive. Positive X direction. Tapos, dito sa kabila ang F2. Okay, so this time, may net force ka na papunta sa left. So, ang acceleration mo, papunta sa right. So, ang acceleration mo is towards the right. Okay? So, yan yung application ng second law of motion. So, the acceleration is equal to your force divided by the mass. Okay. So yan. So the acceleration will just be your net force divided by the mass. So you sum all the forces along a certain axis. So again, the unit of force is newtons. So kung newton ang force mo, kailangan yung acceleration mo is meters per second squared and your mass is in kilograms. Otherwise, yung unit mo hindi pwedeng maging newton. Okay? So you must be certain about which body we're applying it to. So kailangan mag-free body diagram ka para alam mo uh, saan mga forces. So dahil vector nga yung force, minsan simple yung example sa binigay ko kasi eksakto yung force along the x-axis or the y-axis. So we started with a simple example. But now, we can have a situation na yung paghila dun sa crate, pwedeng yung may angle, no? So halimbawa, balik tayo dun sa crate, no? So paano kung yung force mo, hinihila mo sa certain direction. So balik tayo sa may free body diagram. So, paano kung instead of the straight na pull ng rope dyan, paano kung yung pag-pull mo pataas, so may angle, okay? So, paano kung ang hila niya ay pag ganung angle, no? So, this time, hindi na ganun kasimple yung summation of forces, no? So, this time, meron ka ng angle. So, meron ka ng angle dito. So, you have a certain angle of the force. So, meron kang force along x, component niya along x, and meron kang component along y. So, ito yung force mo, total force mo. So, may component ka na along x and component along y. So, ibig sabihin, gagamit ka ng sine cosine, no? So, yung component ng along x, so remember our computation dyan, paano kung along x? So, treat this as a triangle. So, itong adjacent side, and then this is the hypotenuse. So, yung cosine natin, cosine theta, is just your adjacent over hypotenuse. So, that means your force along x is equal to your cosine of the angle, cosine, saan ba theta dito? Then theta. Isipin natin theta yan. Cosine theta times the force. O, lagay ko na lang dito. Bakit? Baka pagkamalan yung x yung times. Basic ko na lang. Okay, so basically, yung force mo dito is just equal to your F times the cosine of the angle. Okay? So, meron ka ng component ng X and component ng Y. So, ibig sabihin, kung may force na pa ganyan, yung dito sa yung dito sa weight mo, magiging less kasi medyo hinila mo siya pataas eh. Okay? So, kung titingnan natin yung net force along Y, hindi na siya just your normal force minus your weight. So, meron ka pang additional force along Y with the normal force minus yung weight. Oh, okay? So yung magiging mag-change yan. So, medyo complicated na kung may mga angles na yan. No? So, may humila dito, tapos may humila doon. So, may component na rin yan. So, i-break down mo pareho. So, halimbawa may two forces ka, tapos meron ka pang weight, tapos meron ka pang normal force. So, i-take into account mo lahat yan. Kaya, importante yung free body diagram. So, again, hindi ko naman sasama to sa, hindi ko to sasama sa midterms exam. So, application na to ng mga laws ng motion. So, for the midterm exam, force is equal to mass times acceleration muna. Okay? Saka na tayo gumamit ng sine, cosine, yung pag-breakdown ng forces along X and along Y. Okay? So again, you must be certain about which body we're applying it to. So the F net must be the vector of sum of all the forces that are act on that body. Only forces that act on that body are to be included in the vector sum. And the net force component along an axis gives rise to the acceleration along that same axis. So meron component along X and a component along Y. Okay, let's try this example. So one or two forces act on a puck. So sa hockey to, no? Meron na ice surface. So yung pang-score nila, yun yung puck. So one or two forces act on a puck that moves over frictionless ice along the x-axis in one dimension. So the mass is 0.20 kilograms. And then yung forces F1 and F2 are directed along the x-axis. So kita mo sa diagram, yung force 1 mo to the right. So 4 newtons. And to the left, 2 newtons. Force F3 is directed at an angle 30 degrees below the x-axis, no? So it has a magnitude of 1 newton. So kita mo yung force mo pababa. So in each situation, what is the acceleration of the puck? Okay? So may mga different situations tayo. So in the first situation, kung force 1 lang yung nag-act on the puck, so since force 1 is 4.0 newtons, then simple lang, no? Since force is equal to mass times acceleration, divide both sides by the mass, then acceleration is just your force divided by mass. So in situation 1, where you just have one force, then force 4 newtons, force 1 is 4 newtons divided by mass.